EDGECAM offers numerous methods of being able to compile toolpaths quickly and efficiently. On this video, I'd like to show you the PCI template macro method, a facility available to all maintained EDGECAM users. Here's a typical milling scenario, but be reassured the function is also available in turning. We have 13 very typical CAM instructions. These tools and cycles are created regularly, and the process is very typical when machining pockets: rough, flatland, profiling, and lastly chamfering to remove the burrs. The contents of our cycle dialogues is usually the same, but we will need to make changes when necessary. To create the template, we simply highlight the CAM instructions, select PCI template from the drop down, and specify the file name and the folder location. In this case, I'll call mine R machining process and leave it on the desktop. If you wish, you can fill in comments. The comments are used to portray information to a colleague, and these appear in the feedback window. The highlighted CAM instructions are now displayed, and I pick the commands that I wish to interact with when the macro is launched, in this case the 4 machining cycles. A template is now created, so let's test it, but on a different component which contains 2D pockets. The macro is launched from the File menu, Macros. Notice the machining window where the CAM data is also appearing. The process pauses, offering up the 4 pre-chosen cycle dialogues. We now have the opportunity to enter new data pertinent to this part and pick the new 2D pocket feature. It's worth pointing out that macros can also be run on wireframe and surface parts, not just 2D models and features. It's open to all components and indeed nearly every single CAM cycle. The macro continues to run with the user checking over the CAM information and making changes where necessary. This is the beauty of the macro. You're repeating proven good production machining methods, thus guaranteeing consistency and at the same time rapidly deploying toolpaths. So in a very short space of time we have completed our component, thus saving many minutes of programming time. Another advantage of the macro is that untrained or indeed irregular users of EDGECAM can still use the system by deploying the macro. We can speed up the whole process by using the combined picks function, and this will have the effect of reducing user inputs. So I'm going to repeat the whole process again, overwriting the original PCI file, but this time I've activated combined picks and I'm only going to highlight the roughing and the chamfering cycles. When the new macro is launched, only these 2 cycles will be displayed. Combined clicks will alter the macro behavior because all the cycle selection data is presented to the user in one go. It's now running the new macro where the input data is now being initially requested, and EDGECAM stores this and reuses it for the profiling and flatland cycles. The roughing cycle is presented because it was highlighted during the template creation, and I simply fill this in as I see fit. And I simply skip through and ignore all the other prompts until the chamfering cycle is presented. Remember, this was the second cycle I highlighted when creating the new macro. I deliberately chose to interact with the chamfering cycle because I instinctively knew it had different user inputs. So let's further test our macro. Let's see, can we repeat the whole process for all the pockets. So I'll delete all the current CAM instructions. I'll rerun the same macro, this time selecting all 3 pockets. And as expected, the roughing cycle is displayed where, if I wish to do so, I can change the input data. I can accept all the other prompts. Notice the CAM instructions automatically being created in the machining window. And lastly, the chamfering cycle is presented where, again, if I wish to do so, I can alter this data. In certain cases, not all the pockets may require actually deburring. Lastly, just for good practice, we'll take it through into the machine simulator and check, do we have good, consistent, accurate machining.